Hello, everyone. Assalamualaikum. Um, all right, this is a short briefing session for Mechanic of Solid and Structure Lab for Lab 2 SEMM 3931. All right, so in this lab, basically we have two experiments. The first one is, let me share the lab sheet so that you can see the lab sheet. This is all right. The first one is deflection of curve bar, and the other one is combined stress. I think so. Right. So you can basically get this lab sheet from the eLab website. Basically, you can download the two lab sheet over there. All right. So the whole idea for this experiment is basically to use whatever theory that you may have learned in the classroom. All right. So in the classroom, you may have been introduced to the theories that very much govern the I would say application of combined stress as well as the curve bar. All right. So the main idea for us, we go to the lab, we want to basically use the equipments, we want to take measurement, and we want to really see whatever you have learned in the classroom. We want to see whether we can get the same measurement of data by using the equipments. All right. So in both experiment, basically you will have data that you can calculate from the design test rig or the design apparatus. Okay, so you have some value that you can get from your calculation, and from the experiment we will get some other value, and at the end you will have to basically compare these two value and try to see what are the differences. If they were to be the same, why is it the same? And if they were to be different, or why is it different? All right. So again, the whole idea is to compare between two values, between two readings, between two observations. The first one is the data from the calculations using the theories, all right, using the formula and all that. And then the other one is data that you get from the experiment. Of course, during this, I would say, online lab session, you are basically given the data for the experimentation, and you're basically, the main task here is to use the theory and the formula to basically calculate the value from the test rig or from the setup and from the parameters given. Then, of course, finally you make the comparison. All right, for the first one, we have this combined stress experiment. You can basically read from the lab sheet. So the main objective of this experiment is to basically to determine the state of stresses in the structure under combined loadings. The second one is to observe the effect of a stress razor. All right, you can basically read by yourself on the theoretical part. Okay, but the most important thing that you need to see here is figure 1. You have the apparatus or the test rig that has been built in the lab. You have one, I would say, torsion cylinder, all right, with those, I would say, label and markings, and of course, the parameters are all given. You can see there are point A and point B at the cylinder. This is where the sensors are attached, the strain gauge. And then for each of the sensor A, you have a length of A from the point of load, and for sensor B, you have LB, the length of the sensor to the loading point. And of course, you have L and you have Q as the other parameter, and the Q is where you put the load. All right. So basically, for this kind of setup, when you apply load, all right, you will have the load data from the data which very much will be given to you by the lab staff. So when you have the profile, the loading profile at Q, you need that to calculate the stresses that basically happen at point A and point B. All right. So you are putting the load here, and we expect some kind of bending, some kind of stresses, strain, and of course, you know, moment or shear at point A and point B. All right. You will be given a specific loading profile for Q. Then you will basically have to use all the formulation to calculate the stress and the strain at point A and at point B. All right, and the material of the property is given here. Okay, and then for that particular cylinder, we are having, you know, we installed the sensor at 3 different position on the cylinder, on the surface on the cylinder. All right, which are very much there are 3 of them displaced by 120-degree angular displacement. All right, so for the 5.0, the procedure, everything is being set up. All right, but that's more or less the step that you need to do. And for this particular procedure, the data is very much given to you. All right, and what you need to do is basically you can read on the 6, and of course in the group you can do all the discussion, and of course provide the report at the end of the discussion. All right, so again, we have given you the data basically. All right, all you need to do is use the theory, use the formula to calculate the stress and strain at point A and B, given all the parameters, given all the setup, and from there, I need you to compare the value that you get from the calculation with the value that given to you by the lab staff for the experimentation, and of course just basically perform the analysis and write the analysis and your opinion of why it is the same, why it's different, why it is not the same or different in your report. Okay, you may basically use table or any kind of graph to help you to describe the what they call that, the findings. All right, so that is very much the first experiment, which is the combined stress. And for the second experiment, you are having deflection of curve bar. Okay, so the same thing goes here. We have experimental data given, all right, in which in the real face-to-face lab, this data you will have to experiment and to get by yourself, all right. But for this particular online lab, the data is very much given. Again, your job is basically to use the test rig, to use the setup with all the measurement and parameters. You have to use the formula to calculate the theoretical output value, and finally just compare the value to the real or to the given data. And from there, you have to make the analysis. And then, of course, you can state your opinion of why is it the same, why is it not the same, and so on, and of course a lot of marks for this lab are very basically given to you based on the findings, you know, that you know, that not directly describe the data from the table or the graph, but more of the insight of what you can learn or you can gain from the experiment. All right, for this for the first one, here you have for the second experiment, you have deflection of curve bar. Here we have the objective is to validate the formula of deflection using the Castigliano's theorem. Of course, you can see a lot of formula inside. You can read on the item number 4 on the theoretical part to see you know, the theory behind deflection of solid objects. All right, you have all this partial diffraction, differentiation of things here. Okay, here we have 2 type of material: the quarter circle bar and quarter circle and a circular bar. All right, so both of them are very much governed by different kind of theory. So you have to use the theory to basically calculate at the point the deflection rate given the different loading condition. All right, in which you can see the loading condition from the data given by the lab staff. All right, and using the information there, you can basically recalculate the theoretical value that you can get using the experimental setup, the test rig, as well as the formulas given. Okay. Yeah, basically all the parameters are given. So I just need you to basically identify and use the right formula to produce the expected output that basically reflects the amount of deflection that occur at certain loading condition. All right, and then you have the number 5, the procedure, and then for both quarter circle bar and for circular bar, and then for the result, you can put the data into the tabular form or the graph. Is depending on your creativity and the way you want to present the data, and of course you have to come up with a good discussion in which I appreciate if you put your own opinion, your own insight, rather than just describing what's in the table or in the graph. All right, because a lot of marks are basically over there. Okay, I think that's all for both experiment. Again, I recap the whole idea of you doing this experiment or even taking this subject is to implement the theory that you may have learned in the class, all right, into the real test rig. Okay, which the test rig, they have their own parameters, they have their own settings, and basically you can use the parameters from the test rig to basically calculate the expected output or result using the theory in one hand, and in the other hand you have to use the experimental method to get the data, and from there you try to see what went wrong. Okay, if you basically get a very I would say minimal error between the calculated value and the experimental value, meaning that you know, the test rig maybe you know, parameters are all okay, every other assumption are all okay. If you get a very big differences or big error between the calculated value and the experimental value, something is wrong somewhere, and you have to identify and of course describe in your own opinion why is it like that. All right, so that's all I think. Thank you very much. Okay.